Algebra 2, section 1110. We're looking at normal distribution. Now, I've been talking about this for a couple sections, kind of leading up to what this is. So first thing we got to start talking about is normal. Within here, we talk about a discrete probability distribution. So in a discrete probability distribution, here we talk about finite. Okay, so we have a finite number of possible events or values. The binomial probability distribution you studied in the preceding lesson is a discrete probability, so it has only a certain amount of things that can happen within here. The events then that we start talking about afterward is continuous probability distribution. Here we talk about an interval of real numbers. So this really tells us an infinite amount of possibilities are there. The data set is so large that the discrete values approximate a continuous. So once again, this will start leading up to this. As we grow in numbers, as we grow in values, as we get more and more and more, pretty soon we can start saying, hey, we got a continuous. And once we kind of get to that continuous, then we can start talking about the curvature of what's happening with our values and how they're relating to each other. So one of the main curvatures that we talk about, and one of the main things you're always tested on, standardized test, for instance, you just took the ACT test. That is the main brunt of what this curve really is talking about, is a normal curve. Okay, so in a normal curve, you'll see I kind of have it drawn on here. It's also known as a bell curve. Okay, so we can add this on here, bell curve. Okay, as you see, it kind of forms a bell shape. And there are some different styles to the bell curve, but overall, when we discuss the normal curve, we have an overall standing that we talk about. So in this normal curve, we start off by having the mean. Okay, so the mean tells us the centerpiece of information. Okay, so the centerpiece of information breaks up 50% below, 50% above. Okay, so this is the 50th percentile. Okay, so we have the 50th percentile right here, 50% below, 50% above. It's that middle. Now, one standard deviation denotes that 68% is going to be within one standard deviation. That means we have 34% here, 34% here. So this would be talking like your C's. Okay, so a C student is your average student. It's that middle student of what we should be. We should see that 68% of the people overall should have C's. Okay, and then once we have that C, we see that 34% are going to be in that lower half of the C, 34% are in that upper half of the C. If we go out another standard deviation, so if you notice this is one standard deviation, this would be another standard deviation, thus making two standard deviations overall, that now is 95% of the people. So if we think about this, this stretches up to a B, this stretches down to a D. We're talking 95% of the people should be from a B to a D. So if you think about your class, 95% of you, so that leaves what, maybe one or two of you that is outside of this. When we talk about 95%, so if I take this 95 and subtract off the 68, so 95 minus 68 leaves me with 27. So that means there's an additional 25% added on the outside. If we take 27% divided by 2, we see that 13.5% is in each of these categories. Okay, so you're going to want to be writing this bell curve down because it's really, or this normal curve down, because this is what we're going to be using for our next sets of data as we start going through and trying to figure out percents of people. So we see 13.5%, 13.5% here. Now, remember this was our C range. This now went up to a B, went up to down to a D. Well, now we're going to have our F and we're going to have our A, right? So let's think about this. within 3 standard deviations is 99.5%. We think about that's what, 4.7% above here? So that means in here we have 2.35%. 2.35%. And this is just your A, your F, okay? Down to an F. We're not even talking past this. Okay, so when we start thinking about everything that goes into it, when people say, oh, I'm gifted, I'm so smart, or I'm extremely stupid, well, guess what? Both are wrong, okay? In order to be gifted, you have to be outside of this 3rd standard deviation. We think about this is 99.7%. That is 0.3% outside. So this is 0.15% or above 3 standard deviations. Also 0.15% are below. So when you think about this, this is really the extremities. This is the extreme. On a standardized test, when you start getting outside of 2 standard deviations, that's when we start seeing problems. Okay, that's when we start seeing, like, if you're down here, maybe you might have an IEP. Maybe you might be on a 504 plan. Maybe you might need some extra help. Not necessarily just directly from you, but you really need extra help from more outside sources. But if you're testing even below this 3rd standard, this is when we start talking about serious issues. You know, when we start talking about the bright students, many of our bright students are in this category right here, maybe outside of 2 standard deviations. But I doubt that we're outside of 3 standard deviations. Outside of 3 standard deviations, we're talking about those child geniuses, where they're graduating college at age 10 or at age 12. They're getting their doctorate degrees by age 15. You know, that's where we start talking about this in here. So this is truly what your IQ test is built on, what your standardized tests are. If we think about 99 percentile is right here, okay? It's not outside that 3rd standard deviation. That 99 percentile still is within 3 standard deviations. So no standardized test really is going to deem that you're outside and being gifted in here. That's when specialty tests really come into play. So how are we going to work with this? What are we going to do? Let's go to number 12. Okay, so I'll need that information, so let's keep it handy right here. I'm going to go to number 12, and my red pen is a little easier to see. So we'll go to number 12. On number 12, it says that our mean equals 45 with a standard deviation equaling 10. It tells us to sketch a normal curve for each distribution, label the x-axis at 1, 2, and 3 standard deviations. So what this is telling us, it's telling us that we want to draw out our normal curve. Okay, and normal curves, once again, will vary. This one doesn't look too normal, but we'll deem it to be. We come in the center here, and this is where 45 is. So that is our mean. Okay, once again, this is our mean right here. Just because of how I drew it, it almost looks like standard deviation, but it's not. It's my mean. Now that standard deviation is going to tell us what we're going out by. So basically, we're saying 45, 1 standard deviation above is going to add 10. So we would have 55, add 10, 65, add 10, 75. If we come down here, and I go the other way, once again, because these are all 1 standard deviation, we should be approximately the same distance. Now we're going to subtract off. So we subtract 10 off, subtract 10 off, subtract 10 off. So we see that, hey, this is what we have going on here. This is our normal curve. Okay, these are our values. So we would look at a mean score of 45. We would see that 68% of the people would be from 35 to 55. 95% of the people would be from 25 to 65, and then 99.7% of the people would be from 15 to 75 on here, whatever this would be working towards. So now let's look at a couple problems so we can kind of see truly what is happening here. So number 16. Number 16 talks about a set of data has a normal distribution with a mean of 50 and a standard deviation of 8. They tell us we want to find the percent that is greater than 34. Okay, so we want to come to our normal curve. Oh, finger got caught there a second. We're gonna draw out our normal curve. Okay. So in the middle of this normal curve, we would have 50. And then we would have, drawing out, once again, we can just quickly do this with a basic calculator. We would have 50 plus 8. That's right, I typed that into the calculator so nobody out there feels stupid. I shouldn't say that, but I just did, so get over it. Okay, so we see we have 58, 66, 74. Going the other way, we would take 50, then minus 8, 42. So we have 42, 34, and then 26. Okay, so it's telling us we want to find the percent that is greater than 34. So here's 34. We want to be greater than that. So I'm just going to kind of go like this. We want to have all of this part of our normal curve. Okay, so we want this, this, this. So if we think about it, kind of going back, okay, I'm just going to kind of quick slide this back over. We have all these parts in here. If we remember, on this side of the mean, right here over, was 50%. This then was 50%, but I don't have everything. I have this 34%, and then I have this 13.5%. So what we're going to do is we're going to say 13.5% plus 34% plus 50%. Now you could have went 34% plus 13.5% plus 2.35 plus 0.15, but that would add up to 50 if we added all those together. So that's why I didn't do that. We add this together and we see that 97.5% is here. Now the other way you could have went about it is you could have said, well, hey, to the left of this, my area that is not shaded, this is 2.35 and 0.1. That's 2.5%. So if this is 100% altogether, I can take 100% minus that 2.5%, give me 97.5%. Two ways to look at these problems, okay? So please do not overthink these problems, okay? Do not make them harder than they have to be. So let's look at number 22. Last example, possibly for the year, depending upon what's going on, if you got this far before a decision was made. Number 22. Number 22 talks about agriculture. It talks about to win a prize at a county fair, the diameter of a tomato must be greater than, so greater than 4 inches. So, the diameter of a crop of tomatoes grown in a special soil are normally distributed with the mean equals to 3.2 inches and a standard deviation of 0.4 inches. We're trying to figure out the probability that a tomato grown in this specialty soil will be a winner, okay? So what happens here is at this county fair, they've always had winners that are greater than 4 inches, okay? So this tomato diameter had a 4-inch diameter for this. We have our specialty soil. We've grown our tomatoes. We're picking a bunch of them and measuring them, picking a bunch and measuring. We're collecting data. And then in collecting this data, we see that overall we have a mean of 3.2. We have a standard deviation of 0.4. Now, what we're going to try to figure out is well, what's our chance that somewhere in this field, somewhere, we have that prize-winning tomato that's going to get us that blue ribbon at the county fair. So, if we look at our normal curve, okay, we look at our normal curve. In the center here, we have 3.2 inches. Okay, so that's our mean. Now, I don't need to worry about going backwards because I want to be greater than 4. 4 obviously is over here, so I still want to be greater than that. So now what we're going to do is we're going to look at drawing out our right side of our normal curve. So if I take 3.2 and I add 0.4, we get 3.6. If I add 0.4, we get 4.0. Then we have 4.4. So when we look at, we want to be greater than 4. That's this area right here. So if we notice, we're outside of 2 standard deviations. So if we come back, we are outside of 2. We have 2.35, right? So we have 2.35% and then 0.15%. So when we add that together, we see that we have a 2.5%. So there's a 2.5%. Even though we have very large tomatoes overall averaging, but our standard deviation isn't that high, and we see that we still only have this 2.5% chance to have this. Now, I mean, a 2.5% chance isn't the worst, but it's just something we start going. So this is what a normal curve does. It evenly breaks up into categories, once again spacing out. And this is one of the big, most important things with that standard deviation where it comes into play is, how far dispersed are we? As that standard deviation gets larger, that's when we see that spread kind of growing in here. Okay, so as you start working through these problems, do realize that you are going to need to know these percentages here. Okay, what percentage is in between here? And once again, be thinking about 50% above, 50% below. This is an entire population that we start relating this to. Okay,